Hi everyone, my name is David Broman. I'm associate professor here at KDH in Sweden, and I'm going to teach you a little bit about how to do fundamental programming in OCaml. And today I will introduce basic types, expressions, let expressions, and if expressions. And to do that, I'm not going to compile or run anything. We're just going to use a REPL, read, evaluate, print, loop kind of environment. And there's one available for free and easy to use here directly in your web browser. So you can, the best thing to learn is to try out. I mean, the best way to learn to program in something is to always just do programming. And so I recommend that you go to this website here, try.ocamlpro.com, and just fire up this editor and then follow along and try out the things that I explain here at the same time, and just pause the video and try it out. Right, so here, this is like the top level where you can enter expressions. So you can, for example, enter an integer number. Let's say you enter number 7, and then it evaluates here to 7. Surprisingly, it's just a number, but it also says here that the result of this is an integer. So see here, and the result is 7. Right. So in OCaml, basically everything is an expression, and then you create these expressions and evaluate values, and they can also define new names. We'll do that later on, but now let's just look at expressions. So if we now enter another expression here, so we add two numbers together, we can see that we are adding 1 plus 3, and we get the result 4. And the type of this expression here, this expression is int, and the resulting value is also an integer, right? And you can do things like, of course, put in parentheses and do other kind of operations and so forth. Here we can see that the 10 minus 3 is 7 divided by 2, and then it kind of rounds off, or not rounds off, it cuts off, so you get an integer. So you got a reminder here actually of 1. So 7 divided by 2 becomes 3. And to get the reminder in OCaml, you just enter, it's called mod. So here you got this, for example. So this is the reminder of 7 divided by 2. Okay, so these are just strings, and you can, these are just integers, and you can multiply and so forth as you want. Let's see of some other basic data types. And then a string is just entered as in most programming languages. You write it like this, and you see that the type is a string. And in OCaml, the basic strings consist of bytes. So you basically encode just the ASCII characters. There are also a lot of libraries using it for Unicode, but we will not go into that right now. So if you want to, for example, to concatenate two strings, you can write like this, hi, and then you write this, y, and you get the connection here. So you see that the resulting string is the concatenation of these two strings. There are also built-in things that if you want to convert a string from a string to an integer, like int of string, and then you write, say, -12, it returns the integer of -12. You can also go the other direction, string of int, and then you write 77, you get the string from the integer representation. What happens if you write like this then? 17 plus 18. Well, you get an error. And this is because OCaml is a type-safe, statically typed language. So it will check that your types are correct during compile time before it actually compiles your program or runs your program. So here you see that 17 is an integer. This operator here, plus, is actually just operating on integers. And then we have the string here. It happens to be a number, but it's still a string. So then it will complain and say you cannot do that. So to be able to do that, you need to explicitly convert it first. So, and then you would say int of string, and then you do 18 here, and then you get the value. So there is no implicit conversion in OCaml. You need to do explicit conversions. Right. So another type is characters. So let's say A here. This is a character, right? And you can write, for example, you can use different kind of functions for getting different information. So if I write string dot get, and then I have some string here, and write number 3 here, this function takes as input here this string and the number 3, and it picks out the third element. And notice that we, as in most languages, start with 0. So 0, 1, 2, 3, and we get the E, and we return the character here. And one thing to notice here, and I showed this before here when we're calling things, when you call a function, so get here is a function. And in OCaml, we are using juxtaposition, which means that you're just separating the arguments to the function using space, one space or more. So here we separate with this space and this space. So in another language, if we call the same function, say in a C-based language or in Python or something, you would probably write like something like this, right? But you don't do that in OCaml. You just have space separation, which is called a juxtaposition. This is how you call or invoke a function, right? And then there's a lot of there are different functions in the standard library. We saw some function here now from the string library, get. We also have from the character library, we can get the actual code of A, which is returning the integer of this character. And this, if you look it up in an ASCII table, you'll see that the ASCII code for A is 65. And the same way you can go from an integer to a character, for example. And this turns out that the ASCII code 98 is lowercase b. So there are a lot of different libraries. And if you look at here on this tab, I go now to the OCaml.org API. So OCaml.org has a lot of interesting information. So go there and explore. But this -API here, you have a list of all the APIs. And when you start to program, it's really good to explore this and check it out. For example, if we just want to look up this, for example, character here. So this is that we just did. We did found the code. Then we go there and we see the documentation. And code here, this is the notation. We'll come back to this when we explore functions more. But here you see that this function code takes a character and returns an integer, right? And the char function here took an integer and returned a character. Right. So if you want to do something, then you can check out these different libraries. All right. So we will also look at floats a little bit. So a floating point number or double precision point number, you write like this, for example. And the type is float. And if you want to add two floating points numbers, you need to have this special way of writing operators. So you always need to use this dot here. And it might feel a little bit awkward, but that's how it is, because right now OCaml does not have any kind of overloading or type classes and so on. So all operators need to have specific types. Right, and then there are also built-in things. If you go to the floating point library, you have the pi, for example. If you want to convert from an integer to a float, you write like this, right? And if you want to go in the other direction, float of 2 int this, it will just cut off and get the integer value out from that float. Right. Okay, so we have some different basic types here. Let's go over to giving some expressions, or actually values, some names. So if I write like this, let x equals to 3 plus 2, what happens then is that I'm writing this expression, and when the program is executed, this expression will be evaluated into the value, and then this variable that we define here using this top let expression, it binds that value to a name, and then this name will be available afterwards. So we see here that now we have a value that a variable x that is bound to something 5. So if we just write x now, we will have we'll get that value, and we can, for example, now use that value and so forth. It's important to notice that in OCaml, the default thing is that you don't have side effects. So a let will not, it's not really assigning a value to a variable, but rather binding. So you cannot mutate or change that value. It's always, you're always creating fresh values. And this is part of doing a more pure functional programming style in OCaml. In OCaml, you can do a non-pure or impure way using references and so on, which is good sometimes, but it's really good to stay in the pure settings as much as possible. All right, so let's go over now to the editor. So here you saw this top level where you can just enter, or the REPL, you can enter expressions. In this try OCaml, you can also write programs directly, which is kind of nice and a simple way to try out things. So if we write this, let x equals to 4 plus 3, or 3 plus 2 maybe, and then let y equals to x plus 10. Now we are adding together x plus, giving x a value, and then we are using that value in another expression to define another value. If you want to run this, you can click on eval here. You can also first check to see that it type checks. So it checks that this is okay, and then you press eval. And what it does then is just putting this into the REPL here, so that you can see that it computed the values. Now both x and y are available, right? And it used this x, which was 5, when it computed the y, so you got 15. Nothing strange here. You can clear this. Okay. Let's look at some more, some other examples. So there is a top level where you write expressions like we wrote x equals to 5 here. We can also write expressions inside expressions. So let's see. Let's say that we have a result value here. Then we can give that another expression, and there are other kind of expressions, just integer expressions. There are also let expressions. So we can write let, for example, temp equals to 3 here. And then we write in. So this means that whatever we write, let something in, means that we get the value. We can, this variable temp here is bound to what is inside here. So if I write here now, let temp equals to 3 in temp, this whole thing, this is an expression, and the result will then be evaluated, and then this name here, res, will be bound to that value. So we can nest as many expressions as we want here. So let's let more equals to temp plus 1. All right, so then we bind value 3 to temp, and then inside when we define more, we use temp and bind that to +1. So now more is 4. And then we can return more, and we can return more plus 10, right? For example. So we have 3 + 1 + 10. And then this value, this expression, when it's evaluated into value, will then become res. So if we can check it and then evaluate it, and we see that res now has value 14. You see here, you can let expressions inside other expressions. But when you write it without the in, it's at the top level, and then it's available in the rest of the file. Right. The final thing that I wanted to just show you today in this video is if expressions and Booleans. So let's go back here to evaluate to the REPL and look at Boolean. So a Boolean can either be true or false. And a Boolean is not the same thing as an integer, as in C and so on. You can mix Booleans and integers because that is typically what the machine is doing. But to be type safe and to be more strict in the way you write programs, Booleans is a specific type here. And let's look at some operations. Like if you write true and false, it becomes false. So and means Boolean and. So if we do this, and on my computer at least, I have to do control arrow up to be able to go back in history. True and true should become true, right? And then if you want to write or, you do this double bar, which then becomes or. If you want to compare integers, it's as usual, less than, for example, 8, and or like 3 bigger than 1. You can also combine this 7. Let's see here, less than 10, or 3 is bigger than 1, for example. This is how you write expressions about integers and Booleans, and this is kind of the same thing as in most languages. You can also compare 8 equals to 10, and the structural equality where you compare the structure of the data is in OCaml, you just use one equality sign. There is also a double, but then it's checking the physical part, which means that it will, for example, check pointers. So I would recommend you to really just use the structure one with one equality sign as much as possible, unless you really know what you're doing, right? So you can also then directly compare strings like hi and equals to wow, something that is false. Whereas if you do like hi, should be true, right? And if you want to check if something is not equal, then you write like this. Right, this is not equal. Right. Okay, so these are just some Boolean operators. If you want to write an if expression, so if expression is an expression that evaluates to a result, it's not like in C or Java or Python when you just have or when you have a if statement, because then if you have a statement, an if statement, you need to have side effects. So if expressions evaluates to a value, and you simply write if, and then the guard. So let's see if say 7 is larger than 2, then, so this should be true then, right? Then we return 5, else return 10, for example. So yes, this is true. That's why we return the first and the true expression and not the false expression. So if expressions, you always have to have this must be a Boolean type. So you must be evaluated a Boolean. So if true is directly a Boolean, but you can write any kind of expressions, of course, like the one that we had before here, inside the if expression. Anything that in the end evaluates into a Boolean. The other important thing is that these two different, the true expression and the false expression needs to return the same type. So if I write just true here, then hi, else no, it returns hi here, right? But if I write something that is not true, like 8 is less than 2, which is not true, then we get no. These ones needs to have the same type. So if I change this to 8, then it will be different types depending on this value. And if you do that, you will get a type error. So the compiler complains, and now it says that this is really a type that it should be an int. It says it expects a type of string, but you have an integer. And it's because it first looks at this expression, says, okay, it's supposed to be a string, but now you got an integer, so please change it. But it's like you can just change so that you get the same type. That's the main point. Okay, so this is what I wanted to say in this first introductory video. And coming up next, we are going to look at more functions and talk more about what types are actually in OCaml. So thank you for listening.